Okay, this is part 1 of polynomials and partial fractions. That means there are 4 videos altogether on this chapter 4. Okay, so we talk about polynomials and identities first. You will learn in this video how to identify polynomials, add, subtract polynomials, multiply, and find the unknowns in the identity. Okay, so these are the 4 main things that you'll be doing. Now, what's a polynomial? Polynomial are these. Okay, you look at the power. The main thing to focus on is the power. The power is not negative and not a fraction. Okay, this part here in the notes, they didn't mention fraction. It cannot be a fraction. So all these are polynomials. The so-called coefficient in front of x squared can be a fraction, but the power cannot be a fraction. Alright? And the word that you need to know, one important word that you need to know is called degree. Degree of a polynomial means the highest power. So the degree of this polynomial is 4. Degree of this polynomial is 3. Okay, coefficient, they are introducing this word. This is a coefficient of x power 4, that's 5. So 1/3 is coefficient of x squared, minus 1 is the coefficient of x squared, 3 is the coefficient of x, so on and so forth. And the numbers, right, without any x term, without any x, is known as the constant term. Okay, and you can actually call polynomial by any number, also any letter of the alphabet. Can be big case or lower case. Now, you just take a minute, you can pause the video to ask yourself whether these are polynomials. Okay, the answers will be reviewed in the next slide. Okay, let's just go through the answer. These two are polynomials. Okay, you may think that this one is not a polynomial, but it's x to the power of 0 or anything to the power of 0. So there is a number, there is an x and there's a power, and the power in this case is 0. 0 is okay for a polynomial. This one power 2, power 1, power 0. But this one power half, then cannot. Okay, this one power minus 1, y power minus 1 cannot. And then this one is x power minus 2, that's why cannot. Okay, let's try and see whether we can add or minus polynomials. Basically, this doesn't mean p times x. This doesn't mean q times x. It means a polynomial in x, and it's called p. This is a polynomial in x, and it's called q. Okay, I can change the letter here. I can change it to y, then all this will be y. I can change it to, let's say, w, then all this will be w. Okay. Now I just go through very fast. I think this one quite straightforward. Basically, it's just add lah. This add to this minus 3 times of this. So you just do the basic. I will not belabor the point. Now, if you're asked to or required to expand this, then you go one by one. 1, 2, 3. Then this other 1, 2, 3. Okay, then you combine all the like terms. Yeah, basically that's it to this. Nothing much. Okay, now we're venturing into identities already. As you know, these two are identicals, right? Identical, and it's just that they look different, but they are true for all values of x. That means whatever x value you put in, from minus infinity to infinity, this left hand side will be equals to the right hand side, the value. Okay, so this is known as an identity, and normally we write 3 lines here to denote identity. Okay, but even if we don't write the 3 lines, it is an identity if the left hand side is always true for whatever values you put in, okay, together with the right hand side. Okay, there are 2 ways to find the unknowns in an identity: the substitution method, okay, and the compare and equate, or you can have a combination of both. Now let's take a look at an example. Now one look at this, the right hand side, you should know that you can put in 0, put in 1, put in 2, put in minus 2 to find all the unknowns. Okay, so this one I'll also run through fast because I think you know. So you put in 1. Why put in 1? Is to make this disappear, make this unknown disappear, make this unknown disappear, so you can find C. Okay, I just quickly run through. I think the only problem you have is in terms of algebraic manipulation. Okay, and some of you are careless, that's why I couldn't get the answer. Okay, okay, just run through the answers. Okay, now we venture to method 2, which is more tedious. Okay, I don't really like to use method 2. If I can, I'll avoid it if I can. And the problem is you may tend to make mistakes when you do grouping, okay, if you're not careful. But as I mentioned, sometimes you may be forced to use compare coefficient method. Alright, so you need to know both methods. It's just that you have to be very careful with your algebraic manipulation. Okay, then you just equate the coefficient, and sometimes you have to solve them simultaneously. Okay, now this quick check you can just try. You can pause the video and try, and then you can check the answer. Yeah. Okay, division of polynomials. How to divide polynomials? Basically, this is called long division. Long division. Then how to write this polynomial, right, in terms of quotient, divisor, and remainder. This one we spent quite some time in class doing it. Okay, so this is just a primary school example. You divide, then they ding dong, like that. Okay, they are just trying to tell you the mechanics or the way of doing this long division is the same for algebra. You divide until the end where this fella cannot be divided anymore. Okay, then you stop. Okay, next. Now, these are just some terms. The original number is called a dividend. Then you go and divide by the divisor. This remainder everybody knows, and the result here is the quotient. So the dividend, which is the original number, is the divisor times the quotient plus the remainder. This is important, okay? As you have seen, there are questions like this that we have done before, and it's important to know the relationship. Okay, next. Okay, let's try to do long division. You can try doing it. I'll just flash the answer. I won't belabor the point of how to do it. But basically, right, it's you take this 2x power 4 divided by, that means this highest power divided by this highest power for the divisor. Of course, you will take 2x cubed and then you write here. Okay, actually you should write here Okay, but if you have been listening to me in class, you should write all in order. Then when something goes wrong, you will know. And the other thing is that you see, when there is a missing term, you must put a 0 there so that you don't get mixed up. Okay, and you take 2x cubed times this, you will end up this. And very importantly, you must put brackets and put a minus. Okay, then you go to the next line. You get this. Okay, so it takes practice, and then now you bring down this other term. Why must we have 2 here? Because there are 2 terms in the divisor. Okay, then you carry on the same old process. Ding ding dong dong, put a bracket. Ding ding dong dong, go. Then you get this. Okay, so I hope you got a correct answer. That's your remainder. Alright, and this is the result. That means the original number is equals to this times this plus the remainder. And just to highlight to you, the remainder, right? The remainder is always the degree. That means the power is always less than that of the divisor. Okay, why? Because if it's more or equal to, right, you can still divide, you see. So that's why this has to be, the degree has to be less than this degree. Degree means x to the power of something. That power, that's called the degree, is the highest power. So the highest power for this actually is x to the power 0. 0 is less than 1. That's what we are trying to tell you. Okay, oh, one term has gone, something like that. Then you go to submit holiday homework. Okay, then you try this. Then I'll quickly go through. Okay, again, apply the same method. Alright, now why must I have 3? Because there are 3 here. Okay, why must I 3? Because there are 3 here. Then you do the same old story, ding ding dong dong, you will get this. Okay, so that's the remainder, and that is the relationship between them. Okay, next okay, we are now examining that means this dividend what is the degree? 4. This divisor, what's the degree? 1. Degree 3. Degree has to be 0. Okay? So can you see the relationship between the degree on the left and the right? It more or less adds up. Okay? And if you have a quadratic divisor, something like that, okay, you first of all check whether you can factorize this or not. I will next time explain more when we do more questions from other school. Right now, I don't think the next few slides they're going to explain much. Okay, but what this slide is trying to tell you is, if you take this divided by this, right, the quotient, okay, quotient has to be degree 2, alright, and then the remainder, it has to be like less than 2. Okay, it cannot be like 3 or whatever, because 3 then something is very wrong, because it won't match. Okay, so you now try to divide this by this. Oops, sorry. And then you see whether you can get the answer or not. Okay, so this is the answer lah. We have done a lot of this. Okay, now we are going now to the remainder factor theorem. The remainder factor theorem is basically, let's say you have this polynomial and then it's divided by x minus 2. Okay, you will have to multiply by a quotient and then you have a remainder. Now bear in mind that the remainder can be 0. Okay, it depends on what the divisor is. Okay, now this is just trying to tell you why the remainder and the factor theorem works. So in this case, right, we're examining the factor theorem. How come when you divide by this, okay, you have to sub 2? Okay, this one I explained before in class. Because when you sub 2 here, like when you do the finding the ABC for identities, right, when you make this 0, then the remainder is the one that remains on the right hand side. Then when you sub in here, that's your answer already. Okay, that's why the remainder factor theorem works. But this is called a factor theorem. Okay, so this is just a general case, but I hope you don't learn it like that, because it could have been 3x plus 2, 3x minus 1, 2x minus 3, 5x plus 1, things like that. So this need not necessarily be coefficient 1, or it could be 2x, 3x, 4x, 5x. So just to let you know, because this can be misleading to some of you, so that's called the remainder theorem. Remainder theorem means you go and throw inside, and then that's your remainder. Okay, but of course from here also the factor theorem comes about. This one, what do you put in? You find the value of x, you equate this to 0, then you find the value of x, then you sub in. Now you must give it a name. Okay, we're not using long division for this. We give it a name, like what I always say, you have to give it a name and then you find the remainder. Okay, ding dong dong, like that. Yeah. Okay, so the whole idea is to make this 0, then R, your remainder is there. Okay, that's it. And then you can substitute half also. Why half? Because when you set this to 0, x equals to half when you make x the subject. Okay, this one if you want, you can go and try the homework. That's it. Alright.